Okay, so let's look at this question. So for this one, it says a circle PQRS with center O. TU is a tangent. Angle PQR is equal to x minus 1 degrees. Angle XPQ is equal to 2y degrees. Angle QSU is equal to x plus 2 degrees. And angle PSR is equal to y. So for this one, we are asked to find the values of x and y. So let's quickly look at, or let's identify some of the angles that were given in the question. So looking at this diagram, see that we have this angle here, 2y is here. We also have x minus 1 here, and then y is also here, and this particular angle is also what? X plus y, x plus 2, yeah. So questions like this, you need to understand it before you start. It's very simple, but if you don't apply the properties, you'll find it very difficult. So this is circle geometry. So we are going to apply some of the properties we already learned in circle theory. So the question says TU is a tangent line and it touches the circle at a point what x. So S is the point where that line what touches the circle. And looking at this, if you look at the diagram, we are seeing that O is what? Center. So let's consider the following lines: SQ, QP, PRRS. So since we have this here, this line here, which is what SQ is what? Is a chord. And then PQ is also a chord. RP is also a chord. RS is also a chord. So if we understand it that way, that all these lines are chords, then we can proceed to find the values of x and y. Okay, so what we have to know is, once we are saying that this is a tangent line, and then we have this angle here, this is a chord, this angle is formed here. So whenever one of the properties in circle theorem, whenever you have angle between a chord and a tangent line at the end of that chord, so that chord ends here, this is the chord here, so the angle formed between the chord and the tangent is equal to the angle at the alternate segment. Have you gotten that? So we are saying that this property is saying that once you have an angle between a chord and a tangent at the end of that chord, it should be the same as what? The angle formed at the alternate segment. Okay. So looking at this, you see that this particular angle here, angle SPQ, this is what? Alternate angle. We can also look at this particular angle here. Yes, we can also look at this particular angle here. So this angle too can also be alternate to this angle. Okay, so it means if here is this angle is what? X plus 2. We are saying that because it is formed between a chord and a tangent, it can be what? Equal to what? The alternate segment. So this particular side is also what? Alternate to this angle. The same thing, we can also say this angle is also alternate to what? This angle. For that matter, that property states that they should be what? Equal. So if we can develop this idea, then we can just say that this whole angle should be equal to this. So why can? And we know this angle as what? X plus 2. And this angle is also what? 2y. So since they are the same, then I can say that x plus 2 should be equal to what? 2y, because we have already said that since this angle is formed between this chord and the tangent line, then is supposed to be equal to what? The angle formed at the alternate segment. And this is the angle formed here. Have you gotten it? And the same angle, we can also say that this angle is also what? Equal to this angle. So this angle becomes what? This. Have you gotten that? So let's see if indeed we can also use another property. Another property, looking at this line, you see that SQ is also what? A chord. If I have a chord here and I have one angle formed here and another angle formed here, this property also states that angles subtended by a chord at a circumference, they are equal. Have we gotten it? Or angles formed in the same segment are equal. So this is what? A chord. And these angles, this angle here and this angle here, these are the two angles at the circumference which are subtended by what? This chord. So that property also holds, because if this property which says angles at circumference subtended by a chord are equal, then it means that property also what? Holds. So it means that this is also equal to this. That's why I have created this to this. So I can group this as this. So I can write x minus 2y, which is equal to negative 2. I can call this equation what? 1. Good. So let me put this equation down. Then let's consider this angle too. Now let's look at this angle and this angle. Remember, initially I said that this line here is also a chord, and we have this particular chord angle here. There's another angle formed here. So we can also use the same property which also says angles at a circumference subtended by what? A chord are equal, or angles formed in the same segment are equal. So this angle and this angle are the two angles formed in the same segment, and these two angles are also subtended by this chord. This line is a chord. So you see that this line, this formed here, have you gotten that? This is an angle, and this angle formed here, have you gotten it? So this angle and this angle, these two angles are sharing the same chord, so they are subtended by this chord, and they are formed at the circumference. Have you gotten that? So since that property also holds, then we can conclude that y is equal to x minus 1. Yes, so we are using the properties in the circuit theorem to find the values of x and y. So if I have this, then I can also write this as x minus y, which is equal to 1. So I can write this as this, and then I will also call this equation 2. Now, once you have this, I know something comes in your mind. What comes in your mind? Which equation do we have now? Now you can think of what? Simultaneous equation. So it means that we are going to solve these two equations simultaneously. Good. So these are the two equations we have now. X minus 2y, which is equal to negative 2. That is equation 1. And we also have x minus y, which is equal to 1. We have it as what? Equation 2. So these are the two equations we are going to solve simultaneously to find the values of x and y. So I can say, so this one we can use elimination method. We can also use substitution. We can also use graphical method. Since we have this equation here, I'm going to use substitution method. So I'm going to use substitution method. So I can proceed and write it as from equation 2. From equation 2, I can make x the subject. If I am to make x the subject, so this is equation 2. If I am to make x the subject, that means I will maintain x and then send this here. Okay, so I can write here as x is equal to 1 plus y. So I can call this equation what? 3. Okay, so once I have this equation, then I can substitute this equation 3 into what? Equation 1. It means that wherever I see x, I'm going to put the whole here, the whole equation there. So this is equation 1. So I'm going to replace 1 plus y by what? X. So I'll write 1 plus y, this, then minus 2y, which is equal to negative 2. I can group like terms. So here I can write it as, okay, so I can write this as what? Negative y, which is equal to negative 2 minus 1. Then I'll get negative y is equal to negative 3. Because this is negative, this is negative, I can write my final answer as, so let me continue from here. So I can write my final answer as y is equal to what? 3. That's the value for y. So how do we find the value for x? So what I will do is I will just substitute y is equal to 3 into any of the equation. By which of them? I have this equation 3 here, which is very simple. So I will just, so let me rewrite the equation 3 again. So which is x is equal to 1 plus y. So this is our equation 3. So wherever I see y, I will just put what? I will just put my y there, or my 3 there. So I'll write x is equal to 1 plus 3, which will give me what? 4. Good. So that's the value for x. So the question demands we find the values of what? X and y. And we got y as what? 3. And then what? X as what? 4. So you can just conclude that therefore the values of x and y are, so what did we get for x? We got 4, and then we got 3 for y. So we can say 4 and 3 what? Respectively. Good. So this answers the whole question. Very simple. So my name is Sir Evans. Okay. This is Mazris TV. Don't forget to subscribe to my channel, share and like. So see you next time. Thank you.